Hey everybody, this week we're going to be going over a primary brain plan, all right, a 3D CRT plan, so 3D conformal radiation therapy. We're going to try to introduce a few new concepts as well. So two of them have to do with the DVH, okay? So if we look at this PTV, if we scroll up and down, it's really on the superior part of the brain, and it's pretty far away from all of our critical structures that we would normally be worried about in the brain. All right, really the only thing we do need to worry about is the actual brain itself, right? The healthy brain surrounding this target. So our goal will be to spare as much of that as possible, and to measure the quality of our plan, we're gonna talk about two new DVH metrics. One is the conformity index, or CI. What that is, it's a ratio of your 100% isodose volume divided by the volume of your PTV. All right, so we're going to look at that. And that, if you have good coverage on your PTV and a good conformity index, that immediately tells you, without even looking at the dose distribution, that your 100% line really is tight against your PTV, which is a good thing. And the next is the gradient index, or GI. All right, and what that is the ratio of your 50% isodose volume divided by the ratio of your 100% isodose volume. Okay, so a good GI index means that your dose fall off is good, right? We want it to fall off from 100% to 50% as quickly as possible. Okay, so we're going to look at those two things. And the next thing, so far in this class, we've only covered coplanar beam arrangements, meaning no couch kicks. All our beams are in the same plane. Today, we're going to focus on introducing some non-coplanar beams. Okay, and I'm going to go over how I choose those angles a little bit. All right, so let's get started. So the first thing I'm going to do is throw 5 fields on. So I typically tell people that a good 3D conformal plan is going to probably you're going to need between 5 and 7 beams. All right. Anything less than 5, and you're really not going to be as conformal as you could be or probably should be for a true 3D conformal plan. Anything over 7, I don't feel like you see a whole lot of benefit, I guess. So I'm not saying you can't have a real 3D CRT plan with less than 5 or more than 7. It's just that's usually the case. And then I usually say if it's a central lesion, you might use 7, 7 spaced equally around the body. Since this volume is so to the left side here, it's very off center. We're probably going to only need like 5 beams. We're going to start with 5, and we're going to put them all on the left side. We're going to try not to put too much dose through, or at least entering through, this contralateral side, right? Because again, the whole point is to treat this PTV, but spare as much of the normal brain as possible. So a lot of people, you can calculate out, your gantry angles and kind of get an perfectly even space. I'm more of a drag and drop kind of guy. So usually when I have something, this far to the side, I still want to try to get a little bit of dose kind of coming at least a little bit from the contralateral side. So I'll rotate field 1 a little bit past 0 here just to get a little bit better dose on this medial side of the volume. Field 2, 3, 4, and 5. So something like that. MLC's a good starting point is always a half cm. It's usually always what I set it at when I first calculate. All right, our prescription is going to be 200 times 30. So what I want to do real quick is I just want to calculate this coplanar beam arrangement, just so everyone can take kind of a mental picture of what that looks like and see how much we can improve our dose fall off with a non-coplanar beam arrangement. So if we do a coplanar beam arrangement and we look at like our 50% line, even our 50 and 60% line, you can see it extends all the way to the front of the brain there. We're definitely treating a large percentage of the brain with that 50% volume, okay? So just take a mental picture of that, and we're going to see if we can do a little bit better job, okay? All right, so how do you pick your angles? So first of all, you can kind of look at the shape of your PTV and choose some good coplanar angles, and then adjust your couch from there. So let's start with our coplanar angles. So if I just blow up this axial slice, let's just focus a little bit on these angles. So what I do is I look at the shape of our PTV. So this PTV is pretty round, so not going to make as big of a difference on this, but a lot of PTVs aren't round, right? And so this process becomes a little clearer. But even on this round PTV, we're going to see what we can do. So this field 1, I'm going to leave this field 1 as is, because again, I want a little, come past 0 a little bit just to get a little bit better medial dose maybe. Field 2, if you look at the shape of our PTV, at least my eye is kind of seeing a little bit of a flatter part right here on this PTV. And again, our goal is to be as conformal as possible. So I'm going to put field 2 kind of right parallel with that flatter section of that PTV, right? So I want to be as conformal as I can on that section of the PTV. Field 3, same thing, I have this little bit of a flatter edge up here, so I'm going to move field 3 a little bit just to match that perfectly right there. You know, maybe it a little flatter right there, so maybe same thing with field 4, I'll get it parallel with that. Looks like it pretty much already is. Then we have this field 5. You know, if we turn off field 5, we look at our fields, we have this kind of, it's a little bit hard to see, but we have this triangle right here of our field edge. Okay, if you follow these MLCs right here, we have this triangle of excess dose going to the brain, right? So I'm going to use field 5 to kind of cut that off. See that? So I'm going to put it basically at 180 down here to kind of cut that little triangle off. So you can kind of look at the shape of your PTV, right, to determine what angles you want to use to get as conformal as possible. Or, of course, if you have certain OARs that you're looking at, you're going to pick your angles in order to best avoid those OARs, right? So let me readjust my blocks here. Okay, so that's just fine-tuning our coplanar angles. So now let's try to see if we can rotate the couch and come up with an even better beam arrangement. Okay, so we're treating a lot through, you know, all this brain up front. So let's see. So this field 1 is, you know, coming right through all this healthy brain, and the PTV is so superior, right? So let's see if we can kick the couch and treat more through kind of the top of the head and avoid a lot of that extra brain. So usually I just, you know, kind of start typing a number in my couch, and I look at what's going on, you know, in all my planes and kind of adjust from there. So if I put 20 degrees in here, you can see the couch rotates, right? So now we're, instead of coming, you know, through the side, we're going to start coming through the top of the brain there a little bit. And you can also look at this picture here a little bit. Let's see. And this just takes some practice, honestly. I have no... You just got to do it, honestly, because it can get a little bit hard to try to figure out what you're doing with all these views once you start kicking the couch. This helps. If you blow this up, you see this picture right here? It'll help you kind of get oriented to where you're coming from. You can also turn on your body contour and get a better sense of where you're entering through. So right now we rotated the couch a little bit. We're still coming through the front of the brain there. Let's see, let's turn these off. You know, I was gonna try to maybe rotate off the front of the brain, but we might need that dose still coming through there. So if we look here, we rotate the couch so that we're coming a little bit lower there, which might help us out. You want to make sure you stay off the eyes or off any of those critical OARs. In general, you want to try to not enter through the eyes or exit through the eyes. If you can avoid entrance and exit through the entire face, that's best. Let's just leave this one here for now, and we might move this later on. I think I'm going to do what I was originally going to do with another angle. So this angle, let's see, let's try going the other way with this one. I think that should be good. So if we look at our beam's eye view, we're kind of, you know, shooting through the back of the brain here. If we rotate our couch a little bit, we're just gonna exit through a little bit less brain, I think. Let's try that out. And then with this field 3, let's do with field 3. Well, maybe field 3 I want to rotate to 40. Let's try that actually. Then field 1, if we put it 90, there, I think I like that better. So now if we turn on all our beams, really don't have any beam, you know, entering through very much brain at all. Of course, we're exiting through brain, which is just unavoidable, but we're not entering through all that, the front of the brain there. So this field 1, I'm doing the same thing that I did with my coplanar beams, right? I'm kind of looking at the shape of my PTV and select this field 1. I put the couch at 90, and then I rotated my gantry up over the head, so we're going to enter through the top of the head. And again, I kind of see a line on the edge of my PTV, so I'm just trying to match that so I can get as conformal to the shape there as possible. You always, when you start rotating your couch all the way to 90 or 270, I really don't, here, what's this field at? 315. I really almost never go all the way up like this and put my gantry this high, because then we're exiting through like the whole body, right? And not that there's anything inherently wrong with that. It might be necessary, and you know, better than not. It's just, I don't know, it kind of weirds me out giving dose to the whole body. So I try to avoid it as much as possible. So there we're exiting through the back of the head, but we're not going to exit through that whole body. And again, I probably wouldn't come straight from this way because we'd be exiting through the whole face. And again, not that that's wrong or anything. It would be super low dose down here. But, you know, your mouth, your eyes, your nose, that's all pretty sensitive tissue. So if we can avoid treating that, we will. All right, so field 1 I think looks okay. Field 2... So ideally, so what I was looking at with field 2, you see this line here on the PTV. Ideally, I would have a beam, you know, parallel to that. I could come from the other side, but I don't want to exit through the right side, all that healthy tissue. So I rotated my beam down a little bit, right? My couch, so that the beam's coming a little bit more from the inferior side. I really don't want to go more than 15 degrees. So as soon as you start rotating the couch toward the patient, or towards the gantry, I mean, sorry. So if you look at this picture, so if we go to 0, the couch is right there. If we go to 345, I'm rotating the couch toward the head of the gantry, right? Anytime you do that, you're at risk for colliding with the couch or the patient, right? So you got to be a little careful. So I don't think I want to go past 15, but that'll still give us some benefit. Anytime you're kicking the couch, so if you're coplanar with all your beams, all of your entrance and exit dose, all your dose is adding up, right? Because those beams are intersecting in the same plane. As soon as you start kicking the couch, now all your dose, it's not adding up in the same plane, right? It's entering and exiting in different directions, and it should make your plan more conformal. That's the whole point. So this 15 degrees is still going to help us out quite a bit. And then this 40-degree couch kick is trying to get kind of parallel with this line up here. I could probably go a little more than 40. But again, the more I rotate, the more body, you know, down here, neck, face, all that. I'll start. Well, it doesn't look like the face, but I'll just be exiting through more of the patient down here. So I don't know. I think we'll try this out and see how it goes. Okay. So that's all set up. So hopefully that made sense to you. Hopefully that was a little bit clear, at least. It's hard to explain just in one quick video. It really takes some practice getting used to looking at all of this information when you start kicking the couch and determining what angles you want to use. So, number one, I'm trying to look at the shape of my PTV and choose angles that are going to conform to that shape as best as possible. Number two, I'm trying to, choose a wide variety of angles and couch kicks to spread out my dose. Number three, I'm looking at my OARs. I don't want to enter or exit through any, specific OAR. In the brain's case, you really try hard not to enter or exit through the eyes and really just the overall face. So if we look, field one, these are the eyes, right? We're clear of the face. Field 2 is good. Field 3 is good. Field 4 is close, but we're good. And same with field 5. So if you keep those things in mind, you should be good to go. Now, if we turn off our fields, if you remember back to what our original coplanar plan looked like, hopefully it's very clear now why you would do a non-coplanar plan. Our 50% line, 60% line is so much tighter to our PTV than it was, right? So just by coming in at those different angles and getting that non-coplanar beam arrangement can make a big impact on the quality of your plan, all right? So that's why we do it. And for your assignment, what we're going to do here is we're going to measure my conformity index and measure my gradient index, and your job will be to beat whatever I come up with. Okay, so for your assignment, I don't care what angles you use. I encourage you to try to find better angles than what I just found. You don't have to use the same angles as me, but you certainly can. But your job will be to beat me, which should be easy, and we'll go over that in a second. So the next step, the next thing I would do is, of course, look at my field weighting. So do I want to adjust my field weighting? Honestly, looking at this, I'm thinking it's looking pretty good. Just having everything even. So if I had any weird streaking, I would handle that with my field weight. But honestly, I think it looks pretty good. So I'm going to leave my field weighting alone. But of course, depending on what angles you guys come up with, you may need to adjust your field weighting. The next thing we want to adjust is our block margin. So if we zoom in, we can immediately see, that our 100% line is extending well past our PTV endpoints, and we're not getting quite enough, in others. And in this case, we're cold medially, which makes sense because all of our beams are on this left side. But that's a good thing because our tumor is very left-sided. So next we'll adjust that, and I'm going to show you a little bit different way to do it than I showed you in class, a little bit easier way. But in class, we went over how to manually adjust your block edges to come up with a really good, really conformal plan. I really suggest you guys do it manually for your assignment. You'll come up with a better result, and you'll for sure beat my plan if you do it manually. But I'm going to show you a little bit more common way of doing it, a little bit maybe easier way of doing it, but it's just you're not going to get as high quality of a result. So if I come here to MLC, I turn my 100% isodose line on in 3D, right? So I can see that cloud. I can see where I'm overdoing it in my block and see where I'm, cold. And instead of this circular, I'm just going to use this elliptical method, right? So what this does, it'll adjust my margin depending on what jaw I'm looking at. So in this Y1 direction, if I look everywhere in that direction, we're overdoing it, right? So Y1, I'm going to cut my block down to 0.2. X1, same thing, I'm overdoing it. We'll cut that down, whoops. Y2, I'm overdoing it over here, but underdoing it over here. So this is why manually would be better. I could adjust them separately, but since I can't do that with this tool, I have to just leave it as is, or I could even open it up since we're cold right here, but I'll just leave it alone. Same thing with X2, I'm going to leave it alone because I don't want to lose any more coverage right here. All right, so we'll adjust that. You could probably come up with a slightly better plan if you do this one at a time, calculate, and then move on to the next, but I'm just going to do all of them at the same time here for speed purposes. So Y2, I'm going to cut down. X1, I got to leave it because I don't want to lose any more coverage right here. Y1, I'll leave. It's so close right there, but X2, we can certainly cut X2 down. Field 3 is an easy one. We're kind of overdoing it everywhere, so I can leave it on circular and just adjust the whole block. Same with field 4. Let's just do the whole thing. Field 5 looks like Y2. We can shrink that down. X1 we can shrink. Y1, it's gonna shrink here too, where we're cold. Let's just take a look though at what it looks like. So see, it does shrink that a lot. It's probably no good. Probably have to put it back to 0.5. Again, manually, we could do a little bit better job. But I'm just showing you another method, and usually doing that is gonna be good enough. But if you really want to come up with the best plan you can, really high quality, very, very conformal, you can manually, adjust those, just like I do in class. So if you forgot how we did it in class, go back in class. You can use that same method here. We just go around in do a couple rounds, couple circles through your blocks, and adjust them accordingly. Come up with a very, very conformal plan. Okay, so before we measure our conformity index and gradient index, I'm going to just show you one round of field and fields here. I'm just going to go through it once. We're not going to finish the plan completely, because I think by now you all understand how to add field and fields and how to go about that process. The only difference here is we now have, a few more fields than we're used to. So I'm going to turn on that 107. And I'm going to start with field 1, and I just go around in a circle. So let's turn off our PTV. Field 1 looks like a good one to add a field in field 2, right? We have a big open area that we can leave open. So that means it's okay to add a field in field. Could probably rotate my collimator to more optimally block this hotspot out, but we should be okay leaving it too. Okay, so usually I tell you guys 3%. Now we have a few more fields than we're used to. So because of that, we need to use a little higher percentage. If we were using 3%, that just wouldn't be enough monitoring units on that field and field. So let's try 6 and see what that gives us. So 3 MU, and that's what I would expect. Probably no use in going less than 3 MU. So 6%, I think, at least on this plan. But really, you could probably experiment with adding a little bit more weight to these field and fields. Field 2 is kind of borderline, but we'll go ahead and add one. Just check if anything happened. So 123.4, 122.2, so it's just barely changing. That a little bit more. No, you see that? It kind of blew up a little bit. That means we lost some coverage, so I need to go back to 8. Technically our hotspot did go down, so it is doing something. Okay, so here's an example. So field 3, the whole field is hot, right? Can't really do anything yet with field 3, so we'll skip it for now. Ooh, field 4, same thing. We're gonna skip it. Field 5 is a good one though. Okay, now I would start over. I'd go back to field 1, add another field and field. Field 2, same thing. I would still check 3 and 4 because eventually this 107 cloud will start to disappear, right? Eventually it'll start to look better. And I bet you eventually you'll want to add a field and field from field 3 or field 4. So I would still check it, but that's all I do. I just go around in a circle, okay? And I just keep adding one at a time, my field and fields. Eventually that'll go away. So what you'll want to do for your assignment, our goal for this plan is a hotspot less than 108, okay? I expect that you'll be able to get rid of all this 107, so that should be no problem. and then you're gonna measure the conformity index and the gradient index and beat whatever numbers we come up with right here. We're gonna see what we come up with right here. So every field and field you add should improve your conformity index and gradient index a little bit. So I think no matter what, you'll have no problem beating this plan. Also, I strongly encourage you to manually adjust your block edges like we did in class last week in order to get an even more conformal plan, okay? But let's just go over how to measure the conformity index and gradient index. So the easiest way to do it, at least for the conformity index, is usually you can just look at your PTV, and this column is not usually here, but if you right click on this arrow and view columns, you can, this will be unchecked for you guys, but you could check it, click OK, and it'll show up, and usually it gives you a number right here. I don't know why it's not working and saying NA for me right now. Usually it says NA if you don't have your PTV set as a target, but we do here. So to be completely honest, I don't know why this is not working. If it works for you guys, great. That's all you have to do is you can look at the conformity index right here. I'm suspecting it won't work for you guys just the same as me. But that's okay. We can manually measure. And I'm going to show you two ways to do that. So the first way, we're going to convert isodose level to structure. And we need to do this for the 100% line for our conformity index. We also need our 50% line for the gradient index. Okay, we got our 100. We got our 50. All right, then it's very simple. So conformity index. You can either right click on the volumes and then measure volume. So our 100% is 168.03. And then our PTV, measure volume, 143.91. Or you can also look here. So PTV, it shows volume right here, 143.9. If you turn these on, volume right here. So two different ways to get your volume. Let me, oh, I don't have my phone with me. Okay, 168.03 divided by 143.91. So our 100% line, 100% volume divided by our PTV volume equals 1.167. So 1.17 is our conformity index. Generally, for 3D plan, anything less than 1.2 is pretty good. You can't really complain about a conformity index less than 1.2 for a 3D plan. But usually, I think you can get, especially for just a round target volume like this, and especially in the brain, since we can use such big couch kicks and really get a good non-coplanar beam arrangement, I think you guys could get less than 1.1. So I would challenge you guys to try to get less than a 1.1 conformity index, but 1.17 is what you need to do to get full points. All right, and then the gradient index is just your 50% volume. So 376.7 divided by your 100% volume. 168, 2.24. Okay, so you need to beat that number in order to get full points. The other method, if you don't want to convert isodose levels to contours, the other method is if we look here, we can turn all our structures off in our DVH, turn just the body contour on. If you right click, go to absolute volume, you can then just measure the volume of your body getting whatever dose you want. So if we want to look at 100%, we're at 100% dose, this is our volume. If you want to look at 50%, this is our volume of 50%. So if you notice, they don't quite match up. So 100% looking the DVH method, 170.68. If we come down, look at our contour, 168. It's a little different, right? And that's because contours and dose run on two different grids, right? So when you convert dose to a contour, there's a little bit of interpolation involved. So if you look at our contour, like of our 50% line, see the contour doesn't perfectly match the dose, right? So it's never going to be exact, but close enough. This way, the DVH way, using the body contour, is probably a little bit more accurate, but the contour way is also perfectly fine. So feel free to do that either way. Like I said, usually you can use this conformity index column. I honestly don't know why it's not working. If it doesn't work for you guys, or if it does work, let me know, because I could not figure out why that's not working. That is it. Hopefully that made a little bit of sense. Hopefully you understand a little bit of why we would want to introduce some couch kicks, some non-coplanar beams, and hopefully you understand a little bit better how you would improve the conformity of your plan. Again, the goal here, you have 4 metrics that you're going to be looking at. A, you need at least 95% coverage. B, max dose less than 108%. C, conformity index better than 1.17. And D, a gradient index better than 2.24. All right. If you have any questions, please let me know.